Physical Intelligence, the robotics company committed to developing general-purpose AI models and algorithms that power them, have shown that they have been busy. Recently, they revealed the Pi 3.5. What's interesting about this robot is that the designers decided to spread the robot's brain all over its body. This is a stark contrast to everything we know about nature and robotics, as most beings have their brains in one centralized location. Well, meet the Pi 3.5. A robot that has a piece of its brain on every inch of its body. Thanks to this, the robot has been seen to be able to sense, decide, and adjust within a moment. As such, we have a robot that can notice something that is out of order, so it decides to take care of it there and then. This may be exactly what we need to get robots that can exist outside an organized world. The interesting thing about Pi 3.5, as much as the thing with the brain spread all over the body of the robot may be enough to captivate many who come across the robot, you may find that the really fascinating thing about the robot is that it isn't one single robot. Maybe it is better to say that it is two layers that share a name but handle different tasks. On the one hand, there is one layer that could be referred to as the robot reflexes, while the other layer can be referred to as robot common sense. When we talk about robot reflexes, we are reminded that traditional robots make use of one processor to receive information and process it before going on to act on commands. While this is great in settings such as factories, it has been decided that this isn't the best way for a robot to process information when it is in the chaotic setting of a rowdy living room. In order to make some advancement in such a field, the guys at Physical Intelligence came up with Pi nodes. Just imagine something like a Lego blocks that were built all over the surface of the robot. The thing about those nodes is that each block would have its own sensor rig, its own hookup, and a mini neural network that operates a rapid update role. Thanks to the fact that the brain is spread out, it doesn't need to communicate with a central server. This is faster and more efficient. So much so, it is estimated that the robot is 30% more accurate and 25% more energy efficient than other robots or appliances out there today. Then there is the upper layer that we referred to as the robot common sense. Apparently, in the last few years, those in the world of AI have been supplying a transformer with tons of captioned images and language data into a transformer and hope for the best. Most of these people achieve some success before they eventually fall apart. Turns out that Physical Intelligence didn't like this at all, so they decided to tackle this personally. In order to bring this generalization problem to an end, they put a lot of hard work into data diversity. The first thing that they did was to record about 400 hours of mobile manipulation footage. This involved watching as robots made their way through some homes. They collected the data as the robot walked into walls, chairs, and the corner of the bed. Following this, they added static robot clips that were shot in dozens of other environments. Following this, they got some web soup to add to the mix. We're talking about captioning, VQA, object detection, and verbal instruction sessions. This is where humans coach and tutor the robot so that it can be able to perform complex chores by itself at some point in the future. As a result, we'd find that the robot has a very diverse database of knowledge. A Frankenstein curriculum, if you will. What's important is that this database teaches Pi 3.5 everything from how to hold a pot to how hard you can hold an egg. To make sure that this system is functional, they passed the robot through 2 tests. The first test involved in-distribution cleaning tasks. To everyone's delight, the robot did well, with an 83% task success rate. The second test took things up a notch. Known as the OOD test, this out-of-distribution test was no match for Pi as it scored a 94% success rate in obeying the prompt and finishing the task in an environment where a lot of elements such as the space and the lighting were new to the robot. This is a testament to the training of the robot, because without it, the robot's performance would drop to the mid-70s. To learn more about the robot, the guys at Physical Intelligence also carried out a scaling study in which they increased the amount of training houses to about 100, if not more. This must have helped because the robot's performance improved dramatically. It just shows that this robot may have a ton of potential going forward. Going live. Another interesting thing about this robot is that when it is live, it goes through a verified chain of thought loop every second. The first thing that it does in this process is to generate high-level text though, such as put the slippers away using discrete token decoding. This is exactly how ChatGPT writes sentences. Following this, it slides those whites in without any model swap. Those slides go up to a continuous flow, matching head, that will go on to produce 50 joint angles. Add the fact that the lower node reflexes are so fast, you'd find that the robot can think and approach different tasks almost at the same time. To make sure that it was able to do this in the real world, the robot was trained and tested in many different homes. It was all done without any pre-training or pre-warning too, thereby allowing it to make all the necessary mistakes it needed to make so that they could get over this learning curve. They even went ahead to get a bystander who bumped the arm when it was in the middle of its tasks, so that they could add another element to the challenge. The interesting thing about this is that it never seemed to give up. All it did was adjust to each different challenge or each different change in the conditions it found itself in. Its adjustability does come as a compliment to how well it carries out its instructions. Once you yell precise commands such as fluff the pillow or put the shoes away, the robot would target the exact object you have instructed it to handle. You can even be vague and say something like, "Clean the living room." All you need to do is sit back and watch as the robot handles the task with ease. The ability of the robot to stay live has also been commended. Apparently, when you look at the battery, you'd find that the decentralized design of the robot is fantastic. Each node is believed to only make use of the energy it needs to function, so you'd find that the mobile base can roam longer without having to dock. Another fascinating thing about this robot is its flow matching. Considered to be state-of-the-art, it seems to trump other versions because it's a lot faster than its predecessors that made use of a lot of steps to get things done. This is something that could prove to be important, especially when you have 20 milliseconds between sensor reads and motor pulse. Where are we now? As great as this robot is on paper, a lot of work still needs to be done. Right now, it still makes some mistakes, so they are hoping that the robot will eventually get to the point where it is able to correct its mistakes by itself and learn from its environment by itself. Maybe it can even ask humans questions of its own, questions that it used its own initiative to come up with. Maybe it could even be able to transfer information from 2 or more different hardware, almost like a cloud of some sort. With any luck, they will be able to achieve their goals. If they do, they will have a robot that could prove to be the most adaptable robot out there.